You're welcome to today's class. Today we want to look at arrays, indices, memory addresses, and compiler mapping. So this is the beginning of data structure proper. So, but before I teach you this array, I will give you an illustration, right? That even a market woman will be able to understand what an array is. So in the next class, I will use computer terminologies to actually explain arrays. But in this class, I'll use plain language. So to illustrate this concept, everything that I've written on this board, I'm going to use a classroom system. So, and a teacher. So assuming I have first, what is an array? An array is a collection of elements of the same data type stored in a contiguous memory location and can be accessed using what? An index. So in that definition, I have mentioned the word index, right? I have mentioned memory location, right? And I've also mentioned the word element, right? An array is a collection of elements of the same data type stored in the contiguous memory location and can be accessed by what? Using the word index. So to explain this, I'll use very simple. Let's assume a classroom, right? And we have something like this. We have something like this in the classroom. And then we have floor tiles, that is floor tiles, right? So we are going to do this. Just bear with me. All right. So let's just cut it here. So then let's divide this into this. So here, let's give the floor tiles number 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, and then 112. Now, assuming we have um, three chairs, for example, three chairs like this, right? So we have this one and this one, let's assume. Now, the first chair, we have a name, say Ada, right? We have John on the second chair, and then we have Udwak on the third chair. Now, we give this chair numbers. So this one, we give it 0, and we give this one 1, and then we give this one 2. That is chair 1, chair 1, chair 2, chair 3. But we are giving these numbers like this, 0, 1, 2. Okay. Now, let's assume that each of these chairs are going to take 4, right? 4 floor tiles. 4, for example, we are just assuming that each of these chairs will take 4 floor tiles. So meaning 1, 2, 3, 1, 2, 3, 4. That is like this. So each of these chairs will take 4 floor tiles. So 0, then I'm going to put this one here like this, right? So it means I'm going to clean this, and then clean this, right? So this is 0, which is this one. So we'll do the same thing again for another chair. It will take 4, right? Then another chair will take 4. So we clean this, we clean the inside, and then we clean the inside, right? So we name this one 1, and then we name this one 2, right? So we have 3 chairs in the class, and then we name this. So Ada is here, John is here, and then Udwak is what? Here. But the floor tiles, right? The floor tiles, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? So each of the chairs are occupying 4 floor tiles. Now, we have a teacher. We have a teacher, right? And then we have the school builder. And then we have helper, school helper, right? So these 3 people are going to speak. Now, this school builder is the one that built the school, and he's the one that is interested in these floor tiles. This teacher is interested in these numbers that is assigned to each of the chairs, right? So the teacher is not interested in these floor tiles. Now, there is helper. So if the teacher should tell the helper, go to chair number 2 and bring the child in that chair. So this is chair number 2. So we are having 2 numbers now. We have this number and then this number. So the chair numbers, right, are the ones you refer to as. In that my definition, I told you I had element in the definition of array. I had memory address in the definition, and I had in the index or indices for plural, like this index. So I have this. Now, these children sitting in the chair are referred to as what? The element. The memory address is what? This one. These numbers. These are the memory address. Then the index are what? The chair numbers. Right? Those are the chair numbers. That's what you refer to as index. Now, if the teacher should tell this helper, go and bring the child that is sitting in the chair number 2. What this helper will do simply is what? This helper will convert that instruction to what? To this actual location, which is these addresses, which are what? The pixels, the floor tiles. So the helper will know, will calculate immediately that the first child is sitting on the first address, 100, and it requires 4 floor tiles. So the second child that is on chair number 1 will start from 104. And then the third child, which is sitting on what? Chair number 2, right? Will start from 108. But how is this helper doing that? This helper is using a simple rule, a very simple rule. The helper knows that each chair occupies 4 tiles. That is 4, right? Each chair occupies 4 tiles. So what the helper will simply do is take the chair number, multiply it by what? The 4. So if it is chair 1, it will simply do 0 multiplied by 4 plus the starting address, which is this one, the starting address of the chairs, 100. So this is the simple formula that this helper is going to use to locate the tile number of the chair that is asked to bring. So if I say bring the child that is sitting in chair number 2, the helper will quickly convert it to what? To the what? Floor tiles. So to do that, the helper will simply do, using this simple rule, 100 plus number 2, which is what? 2 times what? 4, occupying 4 position, 4 floor tiles. And that will give you what? 100 plus 8. And that will be what? 108. So the starting address of chair number 2 is what? 108. You can see it. Yeah. Now, if I ask the helper to bring to me the child on chair number 0, so immediately the helper will convert it to what? To the floor tiles. Using that same formula, it will be what? 100 plus 0 multiplied by 4. And that will be what? 100 plus 0. That will give you 100. So the helper knows that he is to go to what? To the floor tiles, 100, and then count 4 floor tiles. The child that's sitting on that chair is what he's going to remove. So the teacher is dealing with what? The index. While the helper is dealing with what? The floor tiles. So the floor tiles number is what we refer to as what? Memory address. So the physical location, right? And the children that are sitting on each of these chairs are what you refer to as what? The element. So that is the simple illustration. So what is an array? An array is what? This collection. An array is the collection of what? Elements of the same data type stored in a contiguous memory location and can be accessed using what? Index. So have this at the back of your mind. The rows of chairs, 1, 2, 3, is what you refer to as what? An array. So in the next class, I am going to teach you properly using computer terminologies to really teach this array, indices, memory address, and the compiler. So in this class, the helper, right? That helper is what you are referring to as the compiler, right? The memory address is what the builder, that is the floor tiles, memory addresses, right? Which the builder constructed. Then the chair numbers, are what you call the what? The index, right? So the teacher in this case is the programmer. The programmer, that is the teacher. So in computer programming terminology, the programmer is dealing with what? The indices. While the CPU, the central processing unit, is dealing with what? Memory addresses. So the guy that does that conversion of the language, the interpreter, that is taking the language of the programmer, which is the indices, and then mapping it to what? To the physical memory addresses that the CPU is going to understand, is what? The compiler. So he's the middleman. So you are having two words: the logical world and then the physical world, right? This. So in this one, you have the indices, right? In this one, you have memory addresses, right? Memory addresses. Now, in between is the compiler that interprets this language to this language, map this to this. But all these things are inside the memory. So that is what I need you to understand. That a programmer is dealing with indices in the array. The compiler is mapping these indices to physical memory location. But all these are happening inside the RAM, which is the memory. So with this simple illustration, I just want to show you array, indices, memory addresses, and compiler mapping. So in the next class, I am going to teach this properly for you to understand. So I should do this simple illustration as a generic class, as maybe a pre-array. If you have come with me this far and you have not subscribed to my channel, please do so. And also give me a thumbs up if you enjoyed this class. So till we see in the next class. Bye-bye.